In this presentation, you will learn how to process structure from motion datasets using Agisoft Metashape. In the previous page on structure from motion software, you can find more information about how to download the software and activate the trial license. Let's start with the interface of the software. This is a general view of Metashape's graphical user interface. At the center, there's the model view where you can observe and modify your model in the different processing stages. Below that, you will find the Photos pane, where all the images used for the production of your model show up. Here, you can enable, disable, or delete certain images and modify the way they are displayed. Next to this, there are the Console and Job panes, which display additional information for the model and its processing parameters. Additional panes can also be enabled via the View menu. On the left, there's the Workspace pane, which includes all the elements comprising your project, for example the number of photos, the points of the point cloud, details for the final 3D model, and so forth. Finally, on the top, there's the Menu toolbar, which includes all tools and functionalities that you can use to generate and modify your 3D model. We'll go through all these in the following slides. You can work with 3 different themes in your workspace: the dark, the classic, or the light theme. You can adjust this via the Tools menu. Depending on the colors and textures of your scene, one theme may work better than the other. I would suggest to start with the default theme and experiment with the others once you have completed the first stage of processing, the alignment of the photos. For this presentation, we'll use the dark theme. First things first. The most important thing to do when you start a new project is to save your file. This may sound very simple, but you will be surprised to know how many students of mine have been working on their projects, coming to realize that they never saved their work, only when the software crashed and they lost all the work. Therefore, you need to make sure to save your work at the very beginning, but also once you complete a part of the process. It may also be handy to save multiple files at different processing stages, so you can go back to the previous stage and not start from scratch if something goes wrong. To save your file, go to File and select Save As. Make sure to use a self-explicit naming convention for your project so as to be able to find the file you are looking for among many others. Now that we're all set, it is time to add the photos to your project. You can do that by either dragging and dropping your photos to the Photos pane or by using the Add Photos icon at the top of the Workspace pane. Once you do this, your images will appear in the Photos pane. Here, you can change how photos are displayed. You can also rotate them, as well as enable, disable, or delete them. If you disable an image, this means that it will not be taken into account in the processing. However, it will remain in the Photos pane. However, if you remove an image, this will be deleted from the Photos pane, but not from your image folder. When you disable photos, a red circle icon will appear on the top right corner. You should note here that Metashape uses the word cameras instead of photos as the naming convention. As you can see in the workspace, chunk 1 is the container of your 71 photos. You can add more chunks in your project and divide your images as you see fit. This is particularly handy if you have large datasets which are impossible to process due to limited computational resources. Therefore, you can divide your dataset in multiple chunks, process each one separately, and then merge them. You just need to make sure that there is enough overlap between the different chunks so that they can be properly aligned later. Once you have your images in the project, you should check their quality. To do that, change the view in the Photos pane to Details. Right-click on one of the images and select Estimate Image Quality. Once prompted, select Apply to all cameras and press OK. It will take anything from a few seconds to a few minutes to analyze the quality of your images depending on the amount of images you have used and the power of your device. Once this has been completed, you will see that next to each image there is a quality factor. Any images that score below 0.5 are of low quality and should not be used in processing. Go through your images and disable those that do not meet the quality criteria. However, you should not remove them from the Photos pane, as you may realize that they are the only photos that capture a particular detail of your scene. In this case, you should try using them to see if they can work for you. In the Details view, you can also notice that all the metadata associated with your images are displayed. For example, the focal length, aperture, shutter speed, and so forth. These are also used by the software to extract 3D information, and therefore it is critical not to modify your images by cropping them or changing the resolution. Masking is probably one of the most critical steps in the processing of a structure from motion datasets. Masks define the areas which the software will use to generate the models. By masking out areas that include unnecessary information or areas that are blurry, you will speed up the processing and also make the alignment of the photos easier and more efficient. You should remember that when photographing objects using a light box, you should always mask their background. To make the masking easier, select a background color that will create sharp contrast with the object. For example, if your object is white, do not use a white background. Also, you should take a photograph of the light box without the object in order to automate the masking, as the software can identify with relative accuracy the area that needs to be masked by comparing the two photos with and without the object. To do that, you will need to select Import Masks from the File menu and use From Background as the method. There are also other options that you could use to generate masks. For example, you can load masks from separate images if you have created the masks in an external software, or generate masks based on the reconstructed model. Let's see how to practically do it. Let's assume that you only want to use the architectural remains in this photo. Start by using the drop-down menu of the Select tool and choose Intelligent Scissors. You can also use any other tool from the drop-down menu, such as the Intelligent Paint or the Magic Wand. You will need to experiment with the different tools and decide which one fits best the type of object or scene you are capturing. For example, the Magic Wand is great if you have uniform areas in your image, such as a white or black background. Using the right tool will significantly speed up the masking process. Start by clicking in the photograph. You will see that a red line is generated. This line should be closed, which means that your last click should be on the same spot as your first click. The idea is that within that line, you enclose a region that will be masked. Once you have created the closed line, you should now use the Add, Subtract, or Invert tools to generate the mask. If you press the Add button in this example, what is inside the red line will be masked, which means that it will not be taken into account by the software. This, of course, is the opposite of what you want, since you want to only keep the architectural remains in the processing. Therefore, you should first invert your selection. Press Invert and then select Add to create the mask for anything that is outside the area you generated. Here, you see the result. Once you have generated the masks, if necessary, you are ready to follow the different steps of the processing workflow. These are Align Photos, Build Dense Cloud, Build Mesh, and Build Texture. We'll go through these in detail. You can access these by the Workflow menu in the toolbar at the top. You should note that only the Align Photos is active at first. The different stages get activated once the previous stage has been completed.
You should select the duplicate option.
Let's start with the first stage, the alignment of
There are
photos.
different tools to edit the model.
Firstly, the software will
Once again,
try to align
you
your
can use the
photos.
Select tool
It will
to
do
select
that by
and
going
delete
through
certain
each of
parts
your
the
photographs to
geometry.
identify common points. That's why the overlap between the photos is an essential requirement. Here, you can also select the different parameters of the process. First of all is accuracy. Higher accuracy settings help to obtain a more accurate estimation of the location from which each photograph was taken. Lower accuracy settings are useful to get a rougher result. You should note that higher accuracy also means more processing time. There are a few more settings worth looking at. In generic preselection, the overlapping is defined by using a lower accuracy setting, whereas in the reference preselection, the software is using the measured camera locations if present. The adaptive camera model fitting setting enables the automatic selection of camera parameters to be included based on their reliability estimates. For datasets that have really good geometry, this might provide more accurate information for the initial alignment. Key points indicate the upper limit of feature points on every image to be taken into account during the processing. A tie point, on the other hand, is a set of key points which have been matched as projections of the same 3D point on different images. It is advised for both key and tie points to use the default values. Finally, if you have created masks for your images, it is important to indicate that in this stage by selecting the Apply Masks to either key or tie points. If Apply Masks to Key Points option is selected, masked areas are excluded from feature detection procedure. If you apply masks to tie points, it means that certain tie points are excluded from the alignment process. In essence, if an area has been masked even on a single photo, this same area will not be taken into account in other photos. This can be particularly useful in turntable shooting scenarios to exclude the background by using only one mask. You should note that the time the alignment will take to be completed entirely depends on the number of images you have used and the computational power of your device. Once this stage has been completed, you should be able to see a sparse point cloud consisting of the points in space that the software managed to extract from your images. There may be cases where you decide to do the alignment process with a certain number of photos, only realizing after the process has been completed that you should have added more, in case, for example, a particular area does not have enough information. Therefore, you may decide to add more images to your project. This is possible without redoing the alignment from scratch. To do that, you should follow the steps below. First, you need to go to Tools, Preferences, Advanced, and select Keep Key Points. Then, you should add the photos in your active chunk and select Align Photos from the Workflow menu. Once prompted, you should uncheck the Reset Current Alignment option. Once done, press OK. Metashape will keep the existing key points and will try to match them with key points detected on the new photos. It's now time to move to the second stage in the process, the Dense Cloud. From the Workflow menu, select Build Dense Cloud. Here as well, you can define the quality of the reconstruction. A higher quality setting generates more detailed and accurate geometry, but it requires significantly longer time for processing. It is important to note that this is the most computationally intensive part of the process. Depending on the processing power of your device, as well as the number of images you have used, this stage can last from a few minutes to even several days. Therefore, you should use the quality setting with caution. This is also the stage when an insufficient amount of memory in your device will result in an error message once the software has consumed all the available power. If this happens, any dense cloud processing done up to that stage will be lost. The depth filtering setting is also worth considering. If there are important small details in the scene to be reconstructed, then you should use the mild depth filtering mode. If the area to be reconstructed does not contain small details, then you could use the aggressive depth filtering mode. Moderate depth filtering mode brings results that are in between the mild and aggressive approaches. You should use this setting with caution, and you should definitely not disable it if you don't have a significant amount of computational power. Once this stage is done, you should be able to see a denser point cloud. Although you may think that this is a solid mesh, if you zoom in enough, you will observe that it still consists of thousands or even millions of points. In cases where you want to modify the point cloud without losing the first one you made, you can use the duplicate option. Right-click on the dense cloud in the workspace pane and choose the duplicate option. This will create a second point cloud that you can modify without changing the original. Also, more than one instances of the dense cloud can be stored in one chunk. In case you want to save the current dense cloud and build a new one in the current chunk, right-click on dense cloud and uncheck Set as Default. This is very useful, especially in cases where you would like to create multiple dense clouds, for example with different quality settings, and you want to keep both to compare the results before deciding which one you will use for the rest of the process. Metashape also gives you the opportunity to edit the generated point cloud. If you want to delete some points, the easiest way to do it is by using the Select tool that we saw earlier when creating the masks. You can directly select points in the point cloud and then delete them by pressing Delete in your keyboard. The pink area in these slides indicates the selected points. From the Model menu, you can also do a gradual selection based on different criteria. There are also more advanced tools for editing point clouds found under Tools, Dense Cloud. For example, you can automatically filter points based on masks or colors. It would be worth experimenting with these tools, especially if you want to delete very specific or too many points that are difficult to select manually. Now it's time to convert your point cloud into a solid, what we call mesh. This is also accessible via the Workflow menu. Here you have different parameters to consider. If your source data is the dense cloud, this means that your mesh will have more detail in comparison to generating it based on the sparse cloud. It could make sense to generate a mesh based on the sparse cloud to have a quick and rough approximation of your final model. However, you should have in mind that this could not be considered representative of the final model. Depth map setting allows to use all the information from the input images and is less resource demanding compared to the dense cloud-based reconstruction. The option can produce good results when the arbitrary surface type has been selected. Regarding the surface type, unless you are working with aerial imagery, you should select arbitrary. This setting doesn't make any assumptions on the type of the object being modeled, but at the same time consumes more memory. The quality setting works in the same way as in the previous processing stages. The face count, on the other hand, lets you choose the maximum number of faces in the final mesh. The higher the number, the more detailed the final model will be. By default, interpolation is enabled. This means that Metashape will interpolate some surface areas around every dense cloud point, trying to cover areas with gaps. If interpolation is disabled, the reconstruction will be more accurate, but this may result holes in areas of the model where there is not enough information. If extrapolation is selected, the software generates a model without holes, which however means that large areas with gaps may be filled with inaccurate or inconsistent geometry. If you have created masks, you can select Strict Volumetric Masking. This means that any area covered with masks from at least one photo will not be taken into account. However, given that its mask is strict, you should make sure if you use them that you don't exclude any unnecessary surface parts. Here you see the result of this stage. In the Mesh drop-down menu, you can select different options for displaying the mesh: shaded, solid, and wireframe. Similarly to the dense cloud, more than one meshes can be stored in one chunk. To do that, right-click on the mesh and uncheck Set as Default. Once you rerun the process, the new mesh will be added to the same chunk. On the other hand, if you want to save this mesh and edit another one, you should select the duplicate option. There are different tools to edit the model's geometry. Once again, you can use the Select tool to select and delete certain parts of the geometry, but also there are more advanced tools found under the Tools menu, Mesh. For example, the Decimation tool is used to decrease the geometric resolution of the model by replacing high-resolution mesh with a lower-resolution one. Metashape tends to produce 3D models with excessive geometry resolution, so mesh decimation is usually useful, especially if you intend to post the 3D model online. You can also use the Mesh Refinement tool to further refine the details of the mesh. The Close Holes tool repairs the model by trying to fill in the geometry in areas where there are holes. Also, the Smooth tools allows you to make the model smoother and remove irregularities on the surface. If your geometry has problems, you should experiment with these tools to explore to what extent you can refine the problematic areas before deciding to reprocess the model or use another external software. If the lighting conditions have been changing significantly during the capturing session, you can use the Calibrate Colors option from the Tools menu before building the texture so you can improve the color in the texturing stage. Calibrate White Balance could be selected if it should also be adjusted. The final step in the process is the texture building. In this stage, the software goes through your photos and tries to map the textures on your reconstructed geometry. The default mode is the generic mapping mode. This works well for arbitrary geometry without making assumptions regarding the type of the scene to be processed. The software tries to create as uniform texture as possible. In the adaptive orthophoto mapping mode, the object surface is split into the flat part and vertical regions and are textured separately. The orthophoto mapping mode produces a more compact texture representation at the expense of texture quality in vertical regions. The spherical mapping mode is appropriate only to a certain class of objects that have a ball-like form. The single camera mapping mode allows you to generate texture from a single photo. The blending mode determines the way that pixel values from different photos will be combined to generate the texture. The default is the mosaic, which blends low-frequency components for overlapping images to avoid seam-line problem while calculating the high-frequency components that determine picture details using a single image. If you encounter issues using the default mode, you should experiment with the alternative options. However, it's better to start with the default. The texture size count specifies the size of the texture and the number of files that it will be exported to. Exporting texture to several files allows you to archive greater resolution for the final model texture. On the other hand, exporting a single file, depending on its resolution, can consume large amounts of memory. Hole filling is by default selected. You should disable it only in case problems occur in the process of texturing. The ghosting filter can be handy in case your scene includes some thin structures or moving objects which fail to be reconstructed. When this is selected, it will try to avoid creating a ghosting effect in the textures. When the process has been completed, to see the textured model, go to the mesh icon in the toolbar and select Textured. Metashape can also change the color of the texture automatically. The Remove Lighting tool, found under Tools, Mesh, smooths out dark and light areas. If you decide to use this tool, make sure to duplicate your model and use the copy for experimentation. Generally speaking, removing shadows and generating light neutral color is impossible. Therefore, you should make sure to have, as much as possible, even lighting conditions in the capturing stage. Agisoft recently released a new software, the Texture Delighter, a free standalone tool designed to remove shadows from model textures. The tool can remove cast shadows and ambient occlusion from 3D models by taking into account user input in the form of rough brush strokes marking lit and shadowed areas. You can use the links provided here to download the software and read the available tutorials. Once you have completed the processing, you can export the model to be used in different applications. For example, you can upload it to an online viewer, you can use it in a computer graphics software package, for example for gaming, or you could 3D print it. You should also note that you can export different stages of the process, for example only the point cloud or the mesh before generating the texture. There's a large variety of file formats that you can export to depending on the intended use of the model. For example, if you intend to 3D print the model in a single color, you could select the STL or PLY formats. If you want to upload the model to an online viewer or to do a multicolor 3D printing, you should select the OBJ format. You should note that some file formats, including OBJs, save texture image in a separate file. The texture file should be kept in the same directory as the main file describing the geometry. And in order to be uploaded to a service, it is often required to zip the file first. Metashape also supports direct uploading of the models to different 3D viewers. One of these is Sketchfab, which we will cover later in the unit. To publish your model online, use Upload Data command from the File menu. Metashape can also generate a PDF report which contains the basic processing parameters of the project, processing results, and accuracy evaluations. To generate the report, go to File, Export, and select Generate Report. Then browse the destination folder and give it a name. Metashape also provides the possibility of batch processing. This means that you can pre-program the full processing workflow by defining the parameters used in the individual processing stages: align photos, build dense cloud, build mesh, and build texture. Once you set these parameters and press OK, the processing will start and continue until all stages have been completed. You should select the Save the Project After Each Step option because even if something goes wrong in the process and the software crashes, you will have at least the file saved with the previous steps completed. Batch processing is also accessible under the Workflow menu. Finally, there's the option for cloud processing. In the early days of Structure from Motion, most processes were taking place in the servers of the software company and not as standalone desktop applications. This meant that users did not have any control over the process. In the last few years, however, software and hardware improvements have enabled a combination of desktop and cloud-based processing. At the time of developing this course, Metashape is developing a cloud processing solution which allows the parameterization of the processing on the desktop application and the actual processing on the cloud. This is particularly useful for users who don't have enough computational resources to process a large amount of photographs on their desktops. As the service is still being trialed, it is offered for free to those with a professional license. This works even in cases where you have a professional trial license. To activate the service, you should do the following. It's worth mentioning a powerful 3D processing tool, MathLab. MathLab is a free software to not only view your 3D models on your desktop outside the software package where they were originally designed, but also to process and edit your 3D models, for example by closing holes, hollowing, cleaning the meshes, performing color mapping and texturing, refining, and so forth. Although it has a steep learning curve, there are many tutorials available, and it might be very handy if your meshes have problems that need to be fixed. This is the end of the presentation. I hope that now you feel more comfortable in processing your own datasets using Metashape. Although it is a powerful and at the same time user-friendly software, it requires lots of practicing, trial and error in order to become expert users. It is important to remember that what you get in processing almost entirely depends on the dataset you have captured. Good luck!